This is Facility Science Podcast number 25. I am Jason Doolittle, and today I'm talking about elevators for the third time. Elevators part 1 and 2 are number 23 and 24 of this podcast, and this is a continuation of those, so it might be helpful to listen to those first before continuing with this one. And you can find my notes about elevators and all the other topics that I've covered on this podcast at facilityscience.com. And if you like this podcast and you want to help me keep making it, head over to facilityscience.com/support. See if any of the support options there appeal to you. Making this podcast does take me quite a bit of time, and delivering it to you reliably costs a little bit of money. So anything you might want to chip in would be helpful. And so now I have just a few more elevator specific topics to cover, and I think I'm going to start with elevator modes. So when you push the elevator buttons, either in the hall to call the elevator or inside the car to choose a floor, the controller has to make decisions about how to service all of the requests generated by those button pushes. For example, if there are calls both above and below the car, should the car go up first or should it go down first? Also, if there are multiple cars in the system, which car should be sent to service a call? And the exact thing we want to happen might be different under different circumstances, but there are also a handful or maybe a couple of handfuls of typical situations where we might want the elevator to act in certain ways. And we define these sort of typical behaviors for certain circumstances in what we call modes of operation or service modes. So I'll describe some of those modes now. And just to note that the exact definition of these terms and the exact features of each mode might vary by manufacturer or even by facility. So first, there's the default or normal operating mode, which I've usually heard called automatic mode for modern automatic elevators. And this is what the elevator does when there's no special condition. And generally what happens here is that the elevator, assuming it's starting at the bottom, say in the lobby, it'll start going up. And on the way up, it will answer any hall calls for people that want to go up. And a hall call is when the people in the hallway that want the elevator to come pick them up, that they push the button in the hallway that generates a hall call. And also on the way up, it will drop people off if it passes the floor that they want to be dropped off at. And it will just keep going up until there are no more calls above the car. So on the way up, it will ignore any down calls. Anybody who wants to go down, it's just going to pass them by and ignore them. And it will also ignore any up calls below the car. So it's not going to turn around and go back down until there are no more calls above the car. And when there are no more calls above the car, the elevator will start to move down, picking up anybody that wants to go down and dropping them off when it gets to their destination and passing all the up calls. So that's the basic default automatic mode for an elevator. It just goes back and forth, up and down, services the ups on the way up, services the downs on the way down. And in buildings with multiple elevators operating as a group, so a group is a situation where you push up the button in the hall to call the elevator, and any of a number of different cars might come and pick you up. In a group situation, each car follows the same basic algorithm, but the controller will then use various criteria to decide which car will service a particular call. So if there are two cars heading up past a floor where there's an up call, we don't want both cars to stop at that floor. Instead, the controller will use its programmed criteria to decide which car will stop to service that call. And this particular version of automatic mode is called selective collective operation. In this terminology, the collective of selective collective means that the elevator will remember all the calls that are made and service them when it gets to them. And this is in contrast to an older concept where an elevator would only service one call and not remember any of the others. Basically, a non-collective elevator would ignore all the calls it got while it was servicing a call, which is not particularly user-friendly. And pretty much all modern elevators are collective in this sense that they collect up the calls that are made and remember them so that it can service them when it gets to them. The selective in selective collective means that while the elevator remembers all of the calls and will eventually get to them, it is selective about the order in which it services the calls. So in the algorithm I was describing above, It will only service up calls when it's traveling up and only down calls while it's traveling down, regardless of the order in which the calls were made. Right? So even though an up call might come while the car is going down, it's going to skip that one and service the downs, so it's selective. And this is in contrast to non-selective collective operation, which means the elevator will service calls in the order they were received, regardless of the direction of travel. So a non-selective collective operation, the elevator will travel down while it was going up to pick someone up if the call comes in that order. And there are some variations of this concept, notably down collective and up collective, or maybe more generally something like toward the lobby collective, depending on the exact configuration of the building. The idea here, and I'll use the down collective version to explain, is that traffic is expected to be from the lobby to an upper floor, or from an upper floor to the lobby, but not from a non-lobby floor to another non-lobby floor. The elevator will take people from the lobby up to their floor, and it will consider all calls from upper floors to be down calls to the lobby. So after the elevator has dropped everyone off on the way up, it will turn around and start servicing the down calls and take them all to the lobby. And my understanding is that selective collective operation that I first described is by far the most common, and we choose the others, so non-selective collective or up collective or down collective or even some other algorithm we might decide to invent when it makes sense in a particular building. And the criteria used to decide what makes sense is that we want to decrease the average wait time. So we want to tailor the elevator operation to the way that people use the building. Now, another sort of variation of automatic mode is peak mode. And peak mode is used when we expect there to be a disproportionate demand in one particular direction. So we generally talk about up peak or down peak. And to illustrate this, you can imagine that between, say, 7 a.m. and 10 a.m., somewhere in that range in an office building, most of the people will be entering the building from the street, so into the lobby or whatever, and taking the elevators up to their offices. At this time, hardly anybody will be coming down to leave the building. And similarly, say between 3 p.m. and 6 p.m., somewhere in there, almost everyone will be coming down from their offices to leave the building, and hardly anyone will be entering the building to go to work. And knowing this, it makes sense that we design the elevator algorithm to account for the expected demand to minimize wait times. And that's what peak mode does. Peak mode can be initiated on a schedule or by a demand algorithm in the controller. So, a certain number of calls are made going up or a certain number of calls are made going down. There's an imbalance in the up versus down in a particular time period. Might initiate this algorithmically by the controller, or we can even initiate these things manually. So up peak mode, this is the idea where everyone's coming in going up, no one's really coming down. So in this particular variant, the controller will park all the cars at the lobby with the doors open, and we'll leave them there until they get filled up. And the controller can tell they're filled up basically by the weight of the people in the car, or maybe just for a certain period of time. And once either the weight limit is reached or the time period has elapsed, it'll close the doors and take everyone up to wherever they want to go, and then come straight back down to the lobby. And the idea is we want to get as many people as possible, as fast as possible, up out of the lobby into where they want to go, because that's where the most of the demand is. And down peak mode operates similarly. Instead of the cars parking in the lobby and waiting, they'll go up to the top and then start collecting everyone down. And then once they reach the lobby, they'll go straight back up to the top, start collecting everyone coming down. And that's for when there's no one coming in, everyone's going out. Now, during these peak times, there are going to likely be people who do want to go the other direction. So the way that's handled varies by building. In some cases, you might have a situation where if there's multiple cars in the building, there'll be only some of them will operate in peak mode and the others will operate on the normal automatic mode. Or maybe they'll just prioritize the ups or the downs, but they'll still pick the other calls up on the way in whichever direction. Again, the details will depend a little bit on the exact situation in the building. Okay, another variant of the automatic mode that is for a special situation is what we call riot mode. And this is for use in a situation where there might be some type of violent or otherwise dangerous or disagreeable circumstance at the street level. So a civil unrest or a riot or some other such situation. And riot mode will basically prevent the doors of the elevators from opening at any publicly accessible floor. So the lobby floors or the parking areas or whatever makes sense for the particular building. So the building occupants can operate within the building. So say in a residential building, they can go about their business inside the building, but avoid problems that might be happening outside the building that they might not be involved with. All right, now there's just a few other sort of automatic variations here. One of them is load bypass mode. And load bypass is activated when the car is carrying too much weight. So too much is defined as some percentage of the maximum capacity of the elevator, and the some percentage is defined by the elevator manufacturer or by the engineer designing an elevator system. In one case, I think it was a manual for an elevator that I was reading. I read that the default for that manufacturer was 80% of maximum load would trigger the load bypass mode, but the percentage was also field configurable in that particular model. And in this mode, the elevator basically is going to ignore hall calls until some people get off the elevator, or until the weight inside the car goes down below the threshold. The idea is that we don't want to pick up more people until some people get off to keep the car from being overloaded. We also have seismic mode or earthquake mode for areas where that's important. And in this particular mode, you might have seismic sensors in the building or in the elevator system, and they alert the controller to a potential earthquake situation. And in this situation, what happens is that all the cars will stop at the nearest floor and open the doors and just stop moving, which is what we want the elevators to do, because if the building's moving, the elevator cars are going to move, and that's maybe bad news for the people that are in them. In some situations, the controller will also decide that maybe less important than stopping at the nearest floor is to move the car away from the counterweight, because that counterweight, if it were to come loose and start swinging, it might crash into the car. So that's the thing. What in some circumstances, we want to get the car away from the counterweight before stopping. Another one is security recall mode, or sometimes called anti-crime mode. And in this mode, what happens is that the car will, no matter what happens, from you make a hall call, you get into the car starts taking you to your floor, but before it takes you to your floor, it will take you to the security recall floor and open the doors. That way the security personnel in the building can check you out. Maybe they're looking for somebody, maybe they're just checking everybody out, and then allow the car to continue on to the destination. It's another automatic mode variation. And then one more, this is one that you might find in a hospital, maybe not, and that's code pink mode. And in code pink mode, code pink is if you go to a hospital where they have babies, code pink is that there's a baby missing. So in some hospitals, they have a code pink mode programmed into the elevator, and so when code pink is activated, the elevators will do a certain thing. Often the thing they'll do is go to a particular floor and open, stop, not be usable. Or it also might put them into security recall mode, where they're going to go take whoever's in them to the security recall floor. So that's code pink mode. So now those were all the sort of automatic operating modes of elevators. So in contrast to the automatic modes where the controller decides how the car or the cars should move, there are various manual modes where a person in the car decides where the car should move. And the first one I'll talk about, sort of the basic one, is independent service mode. And this mode is normally activated with a key switch inside the car. And independent service mode is designed to allow an authorized operator, authorized by the fact that they have the key, to take control of a car for their exclusive use. And in this mode, the elevator will ignore all hall calls, so it won't leave the floor it's on to go pick someone up, and it will keep its doors open until they are closed from inside the car, so manually closed, and it will only travel to a different floor when travel is initiated from inside the car. And then when it reaches that other floor, it will just stay there with the doors open. And in a situation where there are a number of elevators grouped together, independent service mode will only affect the one car in which it is activated. So if we have a group of, say, 4 elevators and we put one of them into independent service mode, the other 3 will continue to operate in automatic mode as normal. And this kind of mode is normally used I've seen it used a lot by, say, cleaning crews in the evening. They'll take control of an elevator so that they can, move their equipment, their trash bins, whatever, up and down as they need to without having to wait on elevators. Also seen it for service elevators, so construction crews that might take control of an elevator so they can move their materials up and down easily without having to wait, leave all their stuff in the lobby or whatever. So independent service mode is used for situations like that. And a variation of the independent service mode is medical emergency services, often called code blue mode. And this is used inside a hospital or other healthcare facility, and it allows a doctor or other authorized person to take control of an elevator, usually with a special key switch outside in the hall, in order to respond to an urgent medical situation. So when code blue service is activated at the key switch in the hallway, the controller will cancel all calls for the selected car and send it directly to the floor where the code blue call was initiated. That car will then ignore all calls except for code blue calls initiated from inside the car. Usually that'll be initiated by another key switch inside the car that the doctor or whoever can then activate code blue in the car and then move the car to whichever floor they need to move it to take care of the emergency situation that they might be in. Often in the medical emergency service or the code blue mode, the code blue is initiated from the key switch in the hallway. The car comes to the floor, and then code blue has to be then initiated inside the car as well. And usually what will happen if that never happens, there'll be a timer. So if that particular car isn't taken over within the timer, it'll return that car to normal service. Okay, and we also have what's called fire service mode, which you might think of as another specialized version of independent service. And fire service is a two-phase mode, similar to the code blue mode, where you have to activate it in the hallway and then activate it in the car. And phase one of fire service mode is initiated either by a key switch in the hallway, like the code blue, and that would be activated by a firefighter responding to an emergency situation at the building, or it could also be activated by a signal from a smoke detector or a fire alarm system. And in the fire service phase one, the car moves to the designated emergency recall floor. And the emergency recall floor will be the floor where the fire recall key switch is. So when the firefighter activates the fire service mode from the key switch in the hallway, the elevator car will come right to where they are. And in some systems, there's also an alternate recall floor. So if the fire detection system detects a fire at the primary floor, the primary recall floor, the car will go to the alternate floor instead. Okay, so when the car reaches the recall floor, it will park there with its doors open and stay there until one of two things happen. Either fire service mode is cleared using the reset function, which is usually available at the same key switch used to activate the fire service phase one to begin with, or the emergency response personnel activates fire service phase two to take control of the car. So this is different from code blue mode, where usually there's a timeout on the code blue. In the fire service mode, there's no timeout. The fire service phase one will remain activated until it's either disabled or until phase two is activated. And phase two, just like the code blue situation, phase two is activated from inside the car by another key switch that's in the car operating panel. And fire service phase two allows the user to drive the car up and down, similar to independent service mode. And the elevator will ignore all hall calls, again, similar to the other modes. And the elevator will take the user to any floor, most likely bypassing any security restrictions, which might be different from the other modes as well. And the doors won't open and close automatically, but instead are open and closed manually by holding the door open and door close buttons, which is the thing we want because the firefighter might decide that it's not safe based on heat or whatever. Maybe there's a fire on this floor. We don't want to let that door open here. We need to keep going or go somewhere else. So that's why the decision about when to open and close the doors is left to the operator in the car rather than done automatically. And in the United States, the exact operation of fire service mode for automatic elevators is defined in ASME A17.1 in section 2.27.3. And the ASME is the American Society of Mechanical Engineers. And A17.1 is safety code for elevators and escalators, which actually defines many, maybe all, of the elevator safety features I've talked about in the series about elevators. And the same standard is used in Canada as CSA B44-07, and CSA is the Canadian Standards Association. Okay, so that's fire service mode. Another manual mode is attendant service mode, and this is what it sounds like, a mode that allows an elevator attendant to drive the elevator up and down. And you might have seen, an old-timey elevator in a movie or something where the guy pulls a lever back and forth to make the car go up and down to take people to their floors. And I guess it's also possible you've seen such a thing in real life, but I've only seen it in movies and maybe cartoons. Anyway, the modern elevators replace the lever with buttons, but some still allow the elevator to be controlled by an attendant. And in this mode, the hall calls will register in the elevator, but the attendant will be able to decide which order to service the calls, whether to go up or down, and how long to keep the doors open at each floor, and that sort of thing. And then there are also usually various inspection modes for different inspection circumstances that allow the elevator maintenance personnel or inspectors to operate the elevator car in ways that are not meant to be done by the average user. So they can do things like open the doors when they're not supposed to be open. They can control the elevator from the top of the car. They can basically operate all the different functions of the elevator independently from each other. And most type of elevator controls might have various modes for this. And I think that's about all I want to say about elevator modes. So the other thing I wanted to cover here is phones in elevators. Elevators are required in most places to have phones in them, and the exact details of how the phone should be operated depend on the exact type of elevator, and that's all defined in that standard I was talking about before. But for the general automatic passenger elevator that you're going to see in most commercial or residential buildings, the telephone inside the car is a safety device, and the purpose of it is to allow someone might be in the car, might be stuck, might have an emergency to be able to reach someone to get help. And so based on that purpose, the general idea that has to happen in elevator cars, there has to be a button that the person in the car can push, and that button should be guaranteed to reach somebody that can help the person. And in a building that has a 24-hour, say, facilities or security staff, that might go to the security desk or the facilities desk. And for a facility that doesn't have that might go to an outside service. And so this two-way communication should have a way to identify to the person at the other end which elevator that they're connecting to, and allow this two-way communication to occur between the car and whoever is supposed to be answering it, so that the proper response can be initiated from outside the car. And also that once this communication is initiated, that communication channel should stay open until it's canceled by the other end. And also you might have in a lot of buildings is a way for somebody inside the building to initiate a call into the car. You might see outside in the hall stations of some elevators, there's a firefighter's phone connection, a jack, a receptacle to plug in a phone, and that is designed to allow someone in the hallway to call into the car to say, let them know that what the situation is, let them know that what's going to happen if the car is going to move, if how they're going to be rescued if they're stuck in there or whatever. And when you have both of these communication mechanisms, you have the call initiated from inside the car to whoever's supposed to answer to help someone who might be stuck in there, and you have this hallway initiated call. The hallway initiated call is supposed to take priority over the communication channel that's initiated from inside the car, with the idea that the person who's calling from the hallway is more in a position to actually help the person that might need help inside the car. And I remember actually the first time I stepped into an elevator machine room, this was quite a while ago, I happened to be working between the IT people and the elevator company to connect a phone line to an elevator. And this was a hydraulic elevator, so we were on the bottom floor of the building. And I remember thinking, wait a minute, we're going to connect the phone line to this panel here. We're connecting it to some terminal blocks in the machine room. But how does it actually get to the phone in the elevator car? That elevator car moves, it moves way up and comes back down. And so somehow this cable and also power and control wiring has to get from the machine room to the elevator, even though the elevator car is going to be moving potentially a very long distance from the top to the bottom. And the answer to that question is what we refer to as traveling cables. And the traveling cables are the cables that travel with the car. And in general, the way the traveling cable works is that the traveling cable is connected at the very top of the hoistway. That's where it's terminated into the elevator control system. So where it's connected into the wiring that goes to the controller, into the telephone wiring, into fire alarm system, whatever it's connected to. That usually happens at the top of the hoistway. And this is the case even with a hydraulic elevator that might have the machine room at the bottom. Usually, not all the time, but usually you'll still have the traveling cables connected at the top of the hoistway. And then they're also connected at the bottom of the car. So what you'll have is the cable hanging from the bottom of the car, looping down and then going back up to the top of the hoistway. And you have to have enough cable on there so that when the car is at the bottom, you just have a little loop. So you haven't just pulled the cable off, right? And so when the car goes all the way up to the top, you have, half the cable hanging down from the car, reaching the bottom, and then the other half is coming up the other side to the top of the hoistway. And traveling cable is a bundle of different wires inside one jacket, although in some cases you might have multiple traveling cables, but often you just have one cable that has different types of wires in it because you need maybe bigger wires to provide power to the car. You need the smaller wires for control, even smaller wires for maybe the communication, the telephone line. And an issue with the traveling cable is that there's potentially a great deal of weight in that cable. So you're going to have a plastic or a rubber jacketed cable with copper conductors in it. But in a very tall building, these cables might be hundreds of meters long, which is a lot of weight. And so they have to be either strain relieved. So there's strain relief connections, but a lot of them have a steel cable going down the middle. And that steel cable is what actually takes the weight of the whole cable. So the steel cable, it gets pulled out of the bundle at the two termination points, so at the top of the hoistway and at the bottom of the elevator car, and secured so that all the weight can be carried by the steel cable. And then that steel cable runs the entire length of the cable on the inside to take some of the strain off of the plastic jacketing and the copper conductors. So that's the traveling cable. And I think that's about all I have to say about elevators for now. You can find my notes for this at facilityscience.com. This is number 25. If you have any questions or comments about this topic or suggestions for other topics you'd like to hear about, you can contact me by email at podcast@facilityscience.com. You can also contact me at facilityscience on Twitter. If you like this podcast and you want to help me keep making it, you can go to facilityscience.com/support and see if any of the support options there appeal to you. And I hope this has been helpful to you, and thanks for listening.